Here we have a SAT math problem. Okay, let's go to the question. If x over b positive c negative a equals to y over c positive a negative b equals to z over a positive b negative c, then what is the value of b negative c times x positive c negative a times y positive a negative b times z? That is, we have to find the value of this expression. Okay, now let me consider the stuff we have over here. Here, these three quantities are equal. Okay, for example, if I assume, I assume 5 as the value of this quantity, that is x over b positive c negative a is 5, then what is the value of this quantity? So this one is also 5 and this one is also 5 because all of them are equal. But I do not know the exact value for each of these three quantities. Okay, let me assume k as the value of the first quantity. Then what is the value of the second quantity? That is also k, and the value of the third quantity is also k because all of them are equal. So let me assume that all these three quantities are equal to k. So that is x over b positive c negative a equals to y over c positive a negative b equals to z over a positive b negative c equals to k. Since all the three quantities over here are equal to k, we can equate each quantity to k separately. First, let me equate the first quantity, that is x over b positive c negative a to k. Then I'm getting x over b positive c negative a equals to k. Okay, now I'm going to solve for x in this equation. For that, I have to get rid of the denominator b positive c negative a over here. For that, I have to multiply both sides by b positive c negative a. Let me do it. Okay, when I do so, this b positive c negative a, b positive c negative a will cancel out. I'm getting x equals to k times b positive c negative a. I've solved for x when I equate the first one to k. Now let me equate the second one to k and solve for y. Let me do it. That is y over c positive a negative b equals to k. Now to solve for y, I have to get rid of this denominator c positive a negative b. For that, I have to multiply both sides by c positive a negative b. Then I'm getting y equals to k times c positive a negative b. And now we can equate the third one to k and solve for z. Then I'm getting z over a positive b negative c equals to k. Now to solve for z, we have to get rid of the denominator here. For that, we have to multiply both sides by a positive b negative c. Then I am getting z equals to k times a positive b negative c. Okay, here I have solved for x, y, and z. Now what I have to do is, in this expression, for this x, y, and z, I have to plug in the stuff for what I got over here, and then I have to evaluate the value of this expression. Okay, now let me continue on the next page. Let's continue. This is the expression for which we have to find the value according to the question. Okay, in this expression, I got the value, the stuff which is equivalent to x and the stuff which is equivalent to y and z as well over here. So for x, we have k times b positive c negative a, and for y, the stuff we have over here. For z, we have the stuff over here. Now I'm going to plug in these stuff for x, y, and z in the expression we have over here, for which we have to find the value. Okay, let me do it. So then we get b negative c times for x. We know that k times b positive c negative a and positive c negative a. Let me write it times y. For this y, we can plug in k times c positive a negative b and positive a negative b times z. For this z, we can plug in k times a positive b negative c. Okay, here when I look at the first term over here, the second term, third term, all of them are multiples of k, because in each term k is multiplied over here. Since all of them are multiples of k, we can factor k out. When I factor k out, so then in the first term we have left b negative c times b positive c negative a. Let me write over here b negative c times, I'm going to write this b positive c negative a as b positive c negative a. That is, I consider this b positive c as single term. Positive k is factored out. Then we have c negative a times c positive a negative b in the second term. Then that is c negative a times, I'm going to write this one as c positive a as single term, negative b positive a negative b. This k is factored out times a positive b. I consider this a positive b as single term, negative c. Okay, let me close the square bracket. Now, k times, here I consider this b negative c as a single term, and here already we have considered this one as single term. Okay, now I'm going to distribute this b negative c to this b positive c and this negative a. When I distribute this b negative c to this b positive c, then I'm getting a b negative c times a b positive C. When I distribute this B negative C to this negative A, I have to multiply this one and this negative A. Then the product of this B negative C and negative A can be written as negative A times B negative C. Okay, the same thing we can do over here. That is, we have to consider the C negative A as single term. It has to be distributed to the C positive A and negative B. Then I'm getting positive C negative A times C positive A negative B times C negative A. I just multiply this C negative A and negative B. I'm getting the product negative B times C negative A. Now I have to distribute this A negative B to this one and this one. Then I'm getting positive A negative B times A positive B negative C times A negative B. Okay, now let me consider the algebraic identity, that is the difference of two squares. So that is A square negative B square. Whenever we have difference of two squares in this form, it can be written in the factor form, that is A positive B times A negative B. Now let me consider this identity in reverse order. That is, I multiply two binomials, A positive B, A negative B. Then the result is going to be the difference of two squares. And the thing what we have to notice in these two binomials here is, so the first term and first term must be same, and second term must be same, and one binomial must contain positive sign, other binomial must contain negative sign. Here let's consider the product of two binomials over here, B negative C, B positive C. So the first term are same, second term are same. So one binomial contains a negative sign, other binomial contains a positive sign. So for the product of these two binomials, what we can do is we can write the difference of two squares, that is A square negative B square, but instead of A we have B, instead of B we have C. So let me do it, K times, so the product of these two binomials is B square negative C squares. That is, I have written this product in the form of A square negative B square. Since we have B at the place of A, I have written B square. We have C at the place of B, I have written C square. And also we can distribute this negative A to this B and negative C. Then I'm getting negative AB. Negative A times negative C will be positive AC. And here the same thing. We have the product of two binomials, C negative A, C positive A. As I explained over here in this identity, the product of these two binomials can be written as the difference of two squares, that is C square negative A square, and we can distribute this negative B to this C and negative A. Then I'm getting negative BC, and negative times negative will become positive BA, or it can also be written as AB. Now we can write this product A by negative B and A positive B as A square negative B square, and here we can distribute this negative C to this A and negative B. Then I'm getting negative AC, and negative C times negative B can be written as positive CB, or it can be written as just BC. Okay, then we get K times, here positive B square, negative B square will cancel out, negative C square, positive C square will cancel out, negative A square and positive A square will cancel out, and negative AB, positive AB will cancel out, positive AC, negative AC will cancel out, negative BC, positive BC will cancel out. Okay, everything is cancelled out, and we just get 0 inside the parenthesis over here. K times 0 is just 0. Therefore, the value of this expression is 0.